Hello all. In the last few sessions we have started with sentence classification. How do we do sentence classification using Rnn'S, and then we have studied about Rnn'S, and then we have studied about sequential labeling. How do we do sequential labeling using Rnn'S? We have seen two different architectures of Rnn'S, which are multi-directional, bidirectional Rnn'S, and we have seen what is POS tagging, what is NER, and what is language modeling. So the last session of this unit is all about how do we generate text using Rnn'S. The most important application, or one of the most important application, is how do we start generating text using Rnn'S from scratch. Okay, so let's see about text generation using Rnn'S. Okay, so in the last session we have discussed about language models, which gives probability to NLP sentences, and they also generate natural language sentences from scratch using language models, right. So when I talk about generating text using Rnn'S, it is one of the most fascinating or interesting application of deep learning in the context of natural language processing. Okay, now we have seen Rnn'S has the capability to process sequential text. So they have this ability to capture what? Sequential dependencies, which are well suited for generating the given text. Okay, now the first thing that we have to understand before we actually start building text generation using Rnn'S, how do we feed the RNN model? How do we feed RNN model? So far in all the models we have seen about, we were talking about sentence tokenization and word tokenization. In fact, we also have paragraph tokenization also. Okay, but when we talk about generating text from the scratch using Rnn'S, we talk about character tokenization. That is, we have to feed Rnn'S character by character. So far we have used tokens, that is words, but here we start building the RNN model to generate text using characters. Okay, so the RNN model that we build here operates on characters but not on words and tokens. This is most important point that you have to understand. Okay, after that, all the RNN models that we have seen so far were operated on words, which means that the input was given as words or tokens. Okay, so practically or theoretically, when we talk about RNNs, RNN can operate on anything. They can operate on tokens, they can operate on words, sentences, and characters also. Okay, sometimes in different forms, like when I talk about speech recognition, audio or video processing, we may get waveforms also. Okay, not just sentences, not just paragraphs, not just words, not just character, but RNNs also can accept the waveforms as inputs, as long as there is something that can be turned into vectors. If I convert the words, tokens, characters or waveforms into vectors, I can process anything in the sequential order using RNNs. Okay. Now, when you want to build these language models, we often feed characters, which also includes white space, punctuations and all that stuff with word length as 1. Okay. If suppose I write I am ASHA, I is one character, space is the second character, A is the third character, M is the fourth character. Okay. So including white spaces and punctuations, we consider everything as characters. Okay. Now the rest of the model working is same like how we have done for the rest of the applications. Instead of taking tokens, here we take individual characters which are first embedded. Initially we have converted the tokens, the words into vectors, right. Here we convert the characters into vectors, the same procedure. Okay, and then we feed that into RNN, which is in turn trained so that it can best predict the distribution over the characters that are likely to come next. Okay, now let us consider two ambiguities or two important points when we talk about feeding characters. Okay, so when I talk about the first case, using characters will definitely make RNN efficient, less efficient. Why? Because the computational cost would be more. Okay, if suppose I take a word dog, okay, if it is a word based RNN, when I process the words or tokens, okay, so at one time step I can update this particular word, but if I go for character based RNN, this dog would receive 3 different elements D, O and G, right. So processing time is more, hence more computation is required, which makes RNN less efficient. Okay. Now there is another case that I want you to consider, that is by feeding characters to RNN you can bypass many issues. What are the advantages? See, the previous case was a disadvantage, less efficient because of more computation. When I talk about this case, when you feed characters to RNN, you can bypass many issues. One such issue that I want to highlight here is out of vocabulary, OOV words, which we have already discussed in the last sessions, right. So, when you train a word based RNN, we usually fix the entire set of vocabulary and then start training, okay. But when it encounters these out of vocabulary words, it does not know what to do with it. We have already seen this problem, right. But when you go for character based RNN, you can still operate on individual characters, because when I go for doggy or dog, if both are different words, okay, but here this doggy is also processed as DOG separately. So when you are using character based RNN, this out of vocabulary problem would be resolved. So these are the two important points that you have to consider. One would be the advantage, that is out of vocabulary words also would be considered, and the second one is disadvantage, that is more computation, which makes RNN less efficient. Okay. Now remaining everything is same. The model generation is same, except that when you are generating the text from scratch using RNNs, we have to use character based RNN. Okay. Now how do we evaluate? Okay. So the first step is to read the plain text data file which generate instances for training the model. So for which we use the same toolkit, which is NLTK. You can use many libraries, okay, other libraries called LNLLP. Okay, I will tell you the reason why we are not using LNLP, because we have started using with all the applications were built on NLTK and SPACY, so hence I am using. But one point that you have to note here is NLTK does not have specific function for character tokenization. We have sentence tokenization and word tokenization in NLTK, but we do not have separate function for character tokenization, but we can do it in different way. Okay. So we does not have any built-in support for character level tokenization, but however we can implement using basic Python strings. Okay. So here I have imported NLTK, I have taken sample text and I am generating list of that particular text. Okay. When I do this list of that particular text, I get separate tokens. Okay. So this is how we do. So when we tokenize the text into individual characters by converting what, by using list of characters. Okay. So though direct function is not available in NLTK for character tokenization, you can do it using basic Python functions. Okay. Now after that, how do we generate? How do I generate the text using a language model? Okay. So the most important thing that you have to consider here is, how do I predict the possible characters that may appear in the next context, that is by using fully trained language models. Okay. Specifically when I talk about this, they can give you the probability distribution over possible characters that may come next, from which you can choose the determine the next character. Like what we have seen earlier, for the probability for the language model will give you the probability of words. Similarly, the probability of characters also would be given here when you use a language model. Okay. For example, if the model has generated T and H, okay, and the language model will be trained on this, which will generate the word E. Okay. So when I get the word E, I may have the word generated as THE, but along with that I may also have THEY, THEM and so on. The words which the characters which were generated were TH, the predicted word was E. So the word which I have formed here is THE, but that does not mean THE is correct, because I also have THEM, THERE, THEY and so on, so on. So here also we will be using our language models. Okay. So if you start this process from token and keep this doing until you reach the end of the sentence, you can directly generate a English sentence from scratch. Everything is same, except that you are feeding the RNN with character instead of words. Okay. Now, how do I generate the tokens? Okay. So, this is a simple Python pseudocode. So, I will take a function called define generate, I will give the initial state, I will start generating the tokens. While token is end, I will keep on updating the function using softmax activation function, and I append that to the empty list and I return back to the tokens. Okay. So, this is a simple Python pseudocode for generating the characters, and I add this to my model. Okay. So, this loops look very similar to the one which we used for updating RNN, but with one difference. What is the difference? We are not receiving any input here. Okay. Do I take any input here? I am using a function which is generating the characters. Okay. So, we are not using any input here, but the characters are generated and feeding them as input. Okay. So, in other words, the RNN here operates on the sequence of characters that the RNN itself generated so far. So, these kind of models operate on pass sequences, and they produce some models which are called as autoregressive models. This is some simple architecture of generating text using RNN. As you can see, here I am not using words, but I am using characters. These characters will have the corresponding character embeddings. We do not call them as word embeddings, we call them as character embeddings, and these are given to the RNN model, that is using update function. You can go for RNN, LSTM, GRU or anything. Using the hidden state, I give it to the linear function wherein I get my predictions. THE the words, TH were the words, E is the predicted word. First I take T, that will be generated, H will be taken. Based on these two probabilities, E was generated. Okay. So, in this way we try to generate text using RNNs. Okay. So, in the previous cases we have used initial state and update functions that are actually used for initializing and update the hidden state, right. But in this context, when you talk about generating text, okay, we assume that the model and its parameters are already trained on large amount of natural language text, and here we are using this softmax function. Okay. So, here we use softmax function which will actually runs the softmax function the given vector, and this linear model which we are using on the top is the linear layer to expand or shrink the size of vector, and then finally the function sample, okay, will return the character according to the given probability. Okay. For example, if the distribution is A 0.6, B is 0.3, C is 0.1, it will say that A is 60% of the time, B is 30% of the time, C is 10% of the time, and so on. So, this way the probability distribution is given, which will ensure that the generated string is different every time, while every string is likely to look like a real English sentence. Okay. So, this is all about how do we generate text using RNNs. The procedure is same. The only thing that we have to note it is we use character based feeding to the RNN architecture instead of words. So, word to word embeddings in the earlier cases, characters as input and the character embeddings, rest all is the same procedure. Thank you so much.